The first time you connect to an MCP server, wouldn't it be ideal to instantly know exactly what tools are available, what parameters they accept, and what the server expects you to do, all without writing manual discovery code? We'll create a FastMCP server with a single tool, then watch the client automatically fetch complete metadata during initialization. You'll see how the capabilities list exposes all registered tool functions with their schemas, how the Async context manager handles both connection and discovery in one step, and why this same pattern works whether you're testing locally with STDIO or connecting to a remote HTTP server. From FastMCP import client, FastMCP. MCP equals FastMCP. Name equals my server. Instructions equals use the greet tool to say hello. At MCP, tool. Def greet name, SDR. Agree to user by name. Return F hello, name. Async with client, MCP as client. Hash initialization, already happened automatically. Print F server, client initialize result server info name. Print F version, client initialize result server info version. Print F instructions, client initialize result instructions. Print F capabilities, client initialize result capabilities tools. This demonstrates the context manager pattern combined with declarative tool registration in an RPC client-server system. The @MCP tool decorator exposes Python functions as remotely callable endpoints, while the Async context manager handles both connection lifecycle and automatic server initialization. The distinctive aspect is how it unifies capability discovery with connection management through a single Async with block. The pattern works by using Python decorators for tool registration and context managers for transport handling, with automatic initialization during context entry. When the client connects, it performs a handshake that populates initialize result with server metadata name, optional version, instructions, and a complete tools inventory derived from all @MCP tool decorated functions. This design keeps server definitions clean while giving clients full visibility into available operations through standardized discovery that works identically across local STDIO and remote HTTP transports. This approach matters because it eliminates RPC boilerplate while maintaining explicit control. The decorator system reduces endpoint registration to single-line annotations. The context manager ensures proper connection handling, and the capabilities system enables clients to dynamically discover and interact with server tools. The pattern is particularly valuable for building testable microservices, creating deterministic automation systems, or developing applications where clients need to understand server capabilities before making calls. Let's break it down line by line. From FastMCP import client, FastMCP. Imports the core FastMCP components. Client for server connections and FastMCP for defining AI callable tools. The @MCP tool decorator exposes Python functions to connected clients, with type hints and doc strings automatically forming the tool schema visible in capabilities tools. This example uses STDIO transport by default, which handles local development communication without requiring explicit server startup. The context manager pattern combines connection and initialization in one step, automatically populating server metadata like name, version, and available tools. MCP equals FastMCP. Name equals my server. Instructions equals use the greet tool to say hello. Creates a FastMCP server instance configured with human-readable metadata. The name parameter identifies the server instance in logs and client connections, while instructions provides default guidance for tool usage. This specific server will expose exactly one tool, greet, through the @MCP tool decorator system. All registered tools appear in the capabilities list during client initialization, with full type hints and docstrings converted to executable schemas.
At MCP, tool. Def greet name, SDR. Greet a user by name.
The @MCP tool decorator registers this function as an AA callable tool, exposing it through FastMCP's interface. The type hints and docstring automatically generate the tool's schema, enabling both programmatic clients and CLI tools to discover and validate the function's signature and purpose. This pattern creates a self-documenting API where tools are explicitly declared rather than inferred.
Return hello, name.
This implements the tool's core business logic by formatting the input parameter into the response string. The f-string ensures type-safe string interpolation while maintaining the exact output schema defined by the @MCP tool decorator's return type hint, which FastMCP uses to generate both the OpenAPI specification and runtime validation.
Async with client, MCP as client.
Async context manager that handles the full client lifecycle, establishes connection, performs automatic initialization handshake, and guarantees cleanup. The example uses STDIO transport by default for local development, with the same pattern working for remote HTTP connections. On entry, it populates client initialize result with server metadata including registered tools, here exposing just the greet function with its name, parameters, and docstring as the schema.
Hash initialization already happened automatically. Print F server. Client initialize result server info name.
This prints the server name from the automatic initialization handshake performed by the context manager. The initialize result contains all server metadata including the optional version field, human-readable instructions, and a capabilities tools list showing all registered @MCP tool functions with their schemas. The same discovery pattern works identically for both local STDIO transport and remote HTTP servers.
Print F version. Client initialize result server info version.
Prints the server's version from the initialization response, which is optional metadata that helps clients verify API compatibility. The capabilities tools list contains all functions registered with @MCP tool, including their parameter schemas derived from type hints and docstrings. This discovery pattern works identically for both local STDIO connections and remote HTTP servers, enabling consistent client behavior across environments.
Print F instructions. Client initialize result instructions.
This prints the server's instructions that were set during FastMCP initialization, providing guidance to both programmatic clients and developers about available tools and their intended usage. The instructions appear alongside the capabilities list, which enumerates all registered @MCP tool functions with their parameter schemas, enabling proper tool discovery and invocation. The context manager pattern ensures the client automatically handles connection setup and initialization in a single operation, working identically for both local STDIO and remote HTTP transports.
Print F capabilities. Client initialize result capabilities tools.
This prints the server's registered tool capabilities from the automatic initialization handshake. The capabilities tools list contains all functions exposed via @MCP tool decorators with their complete schemas, enabling dynamic discovery of available functions and their parameters. This same discovery pattern works identically whether connecting to a local STDIO server or remote HTTP server. FastMCP client discovery. The context manager pattern handles both connection and automatic initialization in one step, exposing all @MCP tool decorated functions through the capabilities tools list with full schema information. The initialize result contains optional version metadata alongside the server's name and instructions, with the same discovery pattern working unchanged across STDIO and HTTP transports. Tools appear in Capabilities tools exactly as defined, with their docstrings becoming the AI-visible descriptions.
The tool that declares its shape becomes every possible conversation